Here's a quadratic application that deals with ratios, a ratio of 3 to 4 on a TV. Now this is the old type of TVs with tubes. So we have an old TV tube that has a screen ratio of 3 to 4. That means for every 3 inches of height you get 4 inches of width. For example, if your screen is a 15-inch high TV, it's going to be 20 inches wide because 3 times 5 is 15 and 4 times 5 is 20. So the 5 in this case is what's called a scaling factor. It increases the size of the TV and, or if it's a fraction, decreases it, a fraction less than 1. Most of the time you want to increase the size of a TV. So all TVs are measured with diagonals, the diagonal length of a TV. So if this is a 3 to 4 inch TV and we increase it, we double its size, then this side is going to be 6 and this side is going to be 8. So what we need to do is come up with a scaling factor. In this case, the scaling factor, I'm going to say x is equal to 2. If x is equal to 3, it would be a 9 by 12 and so forth and so on. Alright, so we don't know what the scaling factor of our TV is going to be, so we just know that we're going to multiply x by 3, but if we do that, we also have to multiply this scaling factor by 4. So this is the picture I want to concentrate on. We're going to draw a diagonal in here for the TV, and we know that this diagonal is eventually going to be 42 inches. So what happens is we get a nice little right triangle. So on this right triangle, it's an ugly drawing, this side is 4x, this side is 3x, and this side is 42. And anytime you have a right triangle and you have 3 of the sides to work with, Pythagorean theorem works rather well. And I usually write Pythagorean backwards. I like c squared equals a squared plus b squared. Only because the hypotenuse, in this case the side opposite the right angle, the longest side, 42 is the number that's most important. I like dealing with it right off the bat. So 42 is the hypotenuse squared, and then a and b just represent the legs, and your legs are 3x and 4x. But be careful, you're substituting in for a, and you're substituting in for b. If you forget the parentheses, you're going to end up with the wrong answer. So a in this case, we'll let it be 3x, b is 4x. So let's see, 42 squared is 1764. When you get to 3x squared, you have to remember your laws of exponents. Everybody gets squared. So this becomes 9x squared. And then when you have the quantity 4x all squared, that becomes 16x squared. And it's not a very hard equation. You have these two as like terms, and 9 plus 16 is 25, so you get 1764 is equal to 25x squared. And then divide both sides by 25. So we're going to get x squared, I like flipping sides, is equal to 1764 divided by 25, which is 70.56. And then to solve it, you're just going to square root both sides. So the exact answer would be this. And we're only dealing with the positive root again because this is a positive number that we can measure. 4 times a negative number would be kind of irrelevant. So the square root of this number and the well, actually it comes out rather exact. The exact answer is decimally 8.4. So this is our scaling factor. This is not the size of the TV. We have to go back and figure out the size of the TV by, well, plugging it back in as a scaling factor. It's 3 times x and 4 times x. So it'll be 8.4 times 3. 3x in this case would become 3 times 8.4. So one of the dimensions, the height of the TV, is going to be 25.2 inches. And the other scaling factor is 4x, so it would be 4 times 8.4. And the length of your TV would be 33.6 inches. So this is a 33.6 by 25.2 inch TV. Has a diagonal of 42 inches. That's all.